Okay, I want to challenge your understanding of the concept of inertia with a fairly simple question. So I want you to imagine you're driving in a car and the car is maybe traveling down the freeway at around, I don't know, 70 miles per hour, which would be roughly the same as what? Maybe 32 meters per second. And you just finished eating an apple and you figure maybe it's not littering, it'll biodegrade, and you drop it out the window. So the force of gravity is going to pull downward. What's the motion? What's the path that that apple core follows when you drop it? Because gravity pulls down, does it fall straight down and the car goes forward? I think the question is, where does the apple land on the ground relative to you? So a lot of people answer that it lands somewhere behind you because it falls down and the car continues to move forward. But if you understand Newton's first law, the idea of inertia, as soon as this apple leaves your hand, it has as much desire to continue moving in a straight line as the car, as you, as the whole system wants to, right? So just as we can treat horizontal and vertical motion as being independent of one another when we studied projectile motion, the same applies here. So the pull of gravity affects the vertical motion, but it doesn't affect the apple's desire to continue this way. So it follows a parabolic path. In the meantime, the truck has advanced this far and it should land directly below you. Now, that's ignoring the effect of air resistance. With air resistance, yeah, it probably ends up landing somewhere behind you. So I want to illustrate this. If you still don't believe it, there's a demonstration we can show. It kind of gets to the heart of the same principle. This is meant to demonstrate inertia. What we have is that's a special cart that has this spring-loaded device on it. So when I load this up with the ball, I think just hitting the on switch here is going to make the spring unload and shoot the ball straight up in the air. It should go straight up and land back down in the container. Let's see. Oh, no, nothing. Okay, watch this. It has a little tab right here, or a slot, and then this has a tab on it. So when the metal tab goes through this slot, it senses it and that'll shoot. Let me try again. Okay, here we go. Sure, goes straight up and down. So we can present a similar case as dropping the apple. Instead of having a force that pulls down, we have a force from the spring that shoots straight up. So I'm going to give this a push. And the question is, does the ball land somewhere behind or does it land straight back down into the cup? So let me just give it a push and let it go and we'll see what happens. Okay, so there you have it.